Hi, everyone. My name is Steve Lawson.
And my name is Anya Fofana.
Thank you for joining us today. We're back here in our SIGNA Pioneer Bay, highlighting the intelligently efficient solutions that we have to showcase this RSNA. So today, we'd like to talk to you about some more of the things around air. Specifically, we're going to talk around abdominal imaging with the air coil.
Yes, and that is why we have our volunteer already positioned on the table, and he is laying comfortably with feet first positioning. And what we are going to do is we are using our new air coil on him, where, as you can see, when I pull the coil into the camera, we do have a lot of coverage. Let me see if the images are okay, or if you can switch the camera.
See for that.
Can they see us?
Yeah. So I think we have to just like rejoin the meeting, and you can see the screen better again. Okay, and then hopefully the camera setup is working so that you can see how large this coil is. So just a little bit in front, so what you will see in a second is the 30-element air AA coil, which has like the 30 elements spread out in columns and in rows. And we can combine this coil with the PA coil, obviously, in the table. And now you can see the coil again. So this is the coil we were just talking about. We have 65 centimeter of skin coverage when you have the coil in this direction. But you can use it also in any other direction. So if you want to put the coil upside down, that's fine as well. You can like wrap the coil around, like for example, long bones, or you can wrap around the coil, for example, when you have a patient who cannot lay on their back for spinal imaging. You can ask them to be in any position they can hold for the time of the spine scan would take, and just put the air coil maybe, for example, on the side of the patient, or maybe on the back of the patient, wherever you want. And that is really the nice thing about the air coils, that you don't have to think about scan groups. Air technology means that we don't have a decoupling when coil elements would overlap. So, for example, when you have to like twist this coil around a joint, which is really small, or you have a really thin patient, and then you can overlap as much as you want without fearing decoupling of signal. Also, if you want to like use that in combination with other coils, you can just overlap as much as you want without fearing to decouple signal. We have 30 elements here in that coil. The Pioneer scanner comes with 32 elements on the table. So again, we have high channel count, and we will use our new coil recognition technique to recognize the coil, so I don't have to worry about that at all. And what will bring us these high channel counts, that is what you will see during the live scanning session as well, is that we can accelerate with factors where we wouldn't be able to do that before. But now let's go ahead and start with the scanning session. I just go and put the coil on the volunteer. You can see we will do an abdominal liver scan. We will use our diffusion technique with navigator, so that means that I don't have to apply any other tools on that patient. So I don't have to like put vessel by him. I don't have to like trigger anyhow. I can just put the coil, put it on the abdomen, and this is like light and the blanket design. You don't have to spread the coil additionally down on him. It just crawls and like really suits his body shape perfectly. If you have a bigger belly, I do just symbolize it here, maybe with my fist underneath. You can see the coil is also like going smoothly around that bulb. So you have always elements close to the anatomy as possible, which is kind of like the new perfect thing about this air coil. But let's go ahead and let him get started into the ward. And then we just start scanning with the liver. So I just do a landmark. I'll also here some improvements. I only have to have a one-click approach to center the patient in the board. No need for me to landmark a coil, or no need to me to landmark anything else. I just use my finger. I don't have to use the laser. And the patient is in the board, and you saw that that approach was only like a 1 mouse click away. Okay, now we go outside and start our scanning session. Okay, you should see now our user interface where we have already the patient data typed in. I have my protocol launched, and now what I will start with is just running the localizer. The abdominal triple localizer is launched. I just hit the save button and I'm going to scan. Yeah. And what I want to talk about here already is that I have the new user interface regarding the coil management, which you see here in the lower right corner. So I do have the air AA coil connected, and I do have the PA coil, which is embedded into the table. And as a user, I don't have to like think about modes or thinking about which part of the coil I'm going to use. I also don't have to tell the system if the coil is like upright on the scanner, or like if it's sideways on the scanner, if it is wrapped around the scanner. All these information will be gathered by the scanner itself, which is really, really convenient. And it will be gathered by itself because we are creating every single time before we run the localizer a sensitivity map. So that is how the system knows how the air coil is in use. So now before the localizer starts, we do a 2 seconds coil calibration scan. And that means that in that time, every single element of the scanner is turned on, and every single coil element in that field of view is active and giving signal to the scanner. So we know exactly where these coils are and how are they positioned, and the system and the software will really decide which elements are needed to give you good image quality. So now we see the localizer is in place, and then we will just start with a T2 sequence and some diffusion sequences. And while these sequences are running, we can also like go ahead and look at some images in an image review. So here, the first thing I want to show you is that you see that without me clicking anything on the user interface, the navigator has been already prescribed and placed on his liver and his diaphragm in a perfect way. That is because the localizer has a post-processing task which says auto tracker placement. So whatever you select at post-processing task, the system will do the tracker placement. And that really helps you a big deal of consistency and again, being efficient, because you can trust the software to find the diaphragm best. So there's no need for the technologists to really make sure that they run a good 3-plane localizer and really move and look how the diaphragm is moving in all 3 planes. It's enough to just like trust the auto prescription here, and it's way easier to start your scanning session. So I will just go ahead, and for the first scan, you will see a T2 with fat saturation, and on top of the navigation, we are using our propeller technique, which is our 2D motion correction. And then I'm going to set up the second sequence as well, which will be a diffusion sequence. Also for that one, we will use the navigator technique. And I will just go ahead and copy the slices here from the slice coverage from the previous scan and the shim volume as well. And we will do the diffusion sequence with 2 different B values. As you can see here, we do have a 50 B value and an 800 B value. We have different numbers of averages. And then on top of that, what we will do is we will use our feature Magic Diffusion to synthesize B values with higher B values. So the 1000 B value will actually not be scanned. It will be synthesized based on those B values which we've acquired in the sequence. Okay. And then while this is running, I want to show you a little bit our navigator. And you see the user interface already here. So our navigator is always accessible while scanning. So that has really huge advantages when you think about your patient and usually what is doing your patient when he comes into the bore and what he is doing the next 2 or 3 minutes. So usually when they are going into the scan bore, they are really excited, they breathe really fast because they don't know what's going to happen. So they have a totally different breathing after a minute. They see, oh, MR is not as bad as they thought. So they will calm down, they will slow down their breath. And usually what happens is that the green line, which symbolizes the respiratory gating, will be way flatter. And on conventional techniques, you will never be able to adjust a sequence while it is running. But with this navigator, you see that you have access to the threshold and the acceptance window the entire time. So if you see, as you can see here, that my volunteer is getting too comfortable and doesn't like really breathe in that much anymore, you can change the threshold as I just did on the fly to make sure that you will always complete your scan. And that really helps you a big deal in real life to make sure that all of the sequences will go and run through, even your patient is not breathing as they started to breathe with. And that's really a tool which I use quite frankly often. Okay, so then maybe while this is running, we can go ahead and look at some cases.
Sure. So over the next couple minutes, we've got some time here while those are running. Let me show you guys a few examples of some clinical results we've gotten recently from our pilot sites, collaborators that are using Air Recon DL as well as some of the other features that come with the DV29.0 software. So, if you watched one of the earlier sessions today, you may have seen the capabilities with Air Recon DL. That can be applied anywhere, really throughout the body. So in this example, it was done on in the abdomen. So this is a single shot T2 weighted acquisition with Air Recon DL. I do have the non-Air Recon DL images also here as well with this little swipe that I'm doing across the image. You can see the improvement in image quality with the Air Recon DL images in regards to the signal, less noise, the sharpness is a lot better. If we were to zoom up on this a little bit, you can see here the edge ringing artifacts that are on the non-Air Recon DL, the conventional reconstruction. Then it really makes all of those artifacts go away and gives you an overall better image with Air Recon DL. So that's a non-fat suppressed scan, but you can also do it on fat suppressed images as well. I think it, these are, whenever you suppress any type of signal in MR, usually you have more of a tendency to have noise come through on those images. So you'll see huge advantage here when using this with fat suppression. So the images with Air Recon DL are here on this left side, but over on the right, we have the conventional reconstructions here. These are all free breath acquisitions. There is an enhancement also with T2s that allow these to be much faster, much higher resolution with something we're calling snapshot, single shot T2 weighted imaging. And it acquires more slices every respiration cycle to allow you to do a bit more in a given set period of time. Now that you can do more slices, it only really makes sense to do thinner slices and do higher resolution imaging. So a lot of people will be using it that way, I think. Here's an example in the coronal plane with Air Recon DL. Once again, a minute 31, 4mm slices. And then, all free breathing. Here's an example of diffusion. So very nice diffusion results here with this 3-minute acquisition here. And then also we're able to do something new. This is a disco star acquisition. So it's a radial 3D volume acquisition. So we're able to get dynamic contrast information just like you would with like a lava. But with this, we're not navigating, we're not doing any type of bellows or anything like that because of its way that it fills the case-based data. it is not going to be sensitive to those types of respiration artifacts or anything. So you can literally just set up a volume, inject, and because of its very fast acquisition time, these are 17 seconds per phase. You're going to get contrast enhancement, great temporal resolution, and nice results with that. And then, so that's Disco Star. We can also come back at the end of the dynamic information, and we can do Lava Star. So a bit longer with this one, but it's designed for high resolution, T1 weighted images after maybe you've given the gadolinium, so about 1.5 minutes for high resolution and T1 weighted scans. If there are any questions, feel free to put those into the chat. Here's another great result here. So another example with Air Recon DL. So images on the right side. This is the conventional reconstructions, Air Recon DL with the swipe on the left side of the screen here. You can see a dilation of the biliary ducts here. Also, there's an area of hepatic steatosis here. So this hyperintense signal here is from that. So patient has steatosis as well as some dilated bile ducts. Looking at the example here, you can see those really nicely on the heavily T2 weighted. This is the conventional reconstruction. You can appreciate how noisy that is. And then with Air Recon DL, we're getting much better results with this as well. So 1.06 minutes for those, once again using snapshot, single shot FSE. Here's just a traditional single shot T2 with Air Recon DL. As I mentioned, this particular patient does have steatosis. So one thing we can do, we can quantify the amount of fat in the liver. So if you wanted to, draw a ROI around the tissue, you can just simply do that with a, I'm doing a freehand trace here, just to kind of just show that area. And then we can see here that the calculation has already been done across this image. So you just really need to put the ROI and get the average value. So that's 31% fat within the ROI. Another free breathing acquisition, Anya's running one or has just completed one. We'll switch back over to Anya in just a minute, but here's an example of propeller T2, 3 minutes and 47, free breathing. Because of this being motion corrected and respiratory triggered, these are going to turn out usually really nice. So very nice to have great results with that. And then also using lava. So just real quick, talk about this. I know we'll switch back over to Anya, but the nice thing about the lavas as well, if you do traditional lava acquisitions, you're able to do that with HyperScent now. So that is a new offering that we're launching this RSNA. So we're able to get great image quality here. The nice thing about doing lava with HyperScent is you can do higher resolution, and then we're able to do some really nice things like do a coronal reformat, for example, and you still can maintain great reconstructions in that plane. So you can tell the coverage here, we've covered quite a bit and still maintain a decent time for that. Okay, great. I'll hand it back over to Anya. Just quickly wanted to review those with you guys. If you have any questions, just feel free to put them in the chat.
Okay, and that is the T2 propeller sequence which we just did on our volunteer. So all in free breathing, as we said, and propeller, as Steve just mentioned, is like our 2D motion correction. And then our diffusion sequence just finished. So we'll do show you guys also the diffusion sequence. So here is the B value of 50, and I just want to scroll through the images here. Also done, as we said, in free breathing with the navigator technique. You see that the images have a really less distortion, and they're really matching the anatomy on the other side. And then I want to switch to the higher B value here, 800. And also you can see here that we still have plenty of signal and a less distortion, which is really nice and relax. It's a good thing. And then we did synthesize data. So I will go and split my layout to a 3 format. So then on the latest sequence here,
want to show you the synthesized data, which hasn't been scanned, but like calculated. And here you will see the 1000 p-value and see that you also have plenty still of signal with these images. So you can set this magic diffusion so to synthesize p-values directly in the protocol so that it's always done automatically. But what you could also do is do that as a post-processing task. So every single time you have acquired two p-values, you can use that tool. So whenever the patient maybe already like left the building, you can still have those images and synthesize them afterwards. You just have to drop on the diffusion image, go here to our session apps, and you have to launch the tool called Synthetic Diffusion. And then you will have that user interface here, which allows you to find any p-value you want. You can neither use here the slider bar or just type in the value you want to look at, maybe 1100, and then you can go from there and synthesize these data and have them also ready for you. Sometimes it's also nice to really like use that tool just for training purposes. So if somebody wants to understand what is happening with the signal when you go higher with the p-value, then it's also really nice to use the slider bar here. I think then everybody understands easily that signal is less when you go higher with the p-value. Okay, then what else did we do? We did like two breath-hold scans here for single shots, just to show you how nice coverage we have. So we did the first one with 28 seconds, and then the second one with 21 seconds. The difference of those two scans is that we use different acceleration factors. So as I mentioned during the coil overview tab, that we have so many coil elements in the field of view. So that really helps you to have higher acceleration factors applied on the sequences, and that again helps you to have shorter breath-hold scans. So here we do have the first single shot with acceleration factor of 2, and then on the right-hand side the acceleration factor of 3. Both have been done with Air Recon DL. And the first thing I want to like show you is just like the coverage of that coil. So you can see here we covered the entire liver and also the entire bladder just in one field of view. And our volunteer has a normal height, so it's not that we have a small volunteer on the table. It's just like I think a standard height. And then on the left-hand side is the acceleration factor by 2, which gives us like breath hold time of 28 seconds. So I set up that sequence that it will do 2 breath holds to make it easy on the patient. But when we use the acceleration factor of 3, I will end up with a breath hold of 21 seconds. So I'm able now to do that really in 1 breath hold time. So with air coils, as I said, you have really a lot of more acceleration fun and time to play with, and you can really have nice scanning results here. So I just want to set up the next scan before we talk a little bit about Air Recon DL again. So you saw already some images, but those 2 images are also both generated with Air Recon DL, because I want to point out here we have a slice thickness selected only for 3 millimeters, and usually they would turn out pretty noisy with that scan time. But since we could use Air Recon DL, we ended up really to have a really good, nice scan time. So we are doing now 1 scan in the prostate. As you can see, air coils cover still plenty of anatomy. So I'm almost like halfway through his thighs. So I don't have to worry about like switching the coils or reposition him or go inside and do a repositioning on that a patient with the coils. I can just plan my field of view here. And what we are going to do is we will have a 3 millimeter slice thickness prostate scan T2, and we do have an resolution of 0.4 by 0.7, which will symbolize the Pirates recommendation here as well. Scan time will be 2 minutes 31, because we can again use Air Recon DL for that, and you can see here on the user interface that we selected the Recon DL strength to high. So, and then while this is running, I want to go back here to my user interface, and I want to show you maybe for the shortest scan, which is on the right-hand side, also the images without Air Recon DL. So I want to just go here and show you that. So you see that we have both the same scan time, 21 seconds, so it's the same scan. but on the left-hand side without using air recon DL, and on the right-hand side with using air recon DL. So when I window level, try to window level at the same, and when I zoom in maybe slightly a little bit more, you can see how much noise has been removed out of these sequences, and that we don't have any issues to really scan thin slices now, because we don't have to worry about the signal, because we can remove the noise, which is automatically happening when thinking about making MR images. Then what we did is another free breathing scan. We did the T1 also in free breathing, and as we just mentioned before, we can also combine HyperWorks now to our T1 sequences. So we did the lava flex sequence. Flex means that we did the Dixon-based sequence, and we did it combined with Navigator. So in case you have to do a dynamic scan, you can still like let the patient breathe however they want, because you can combine it with a Navigator. And then we did accelerate these sequences with HyperSense 2 to really have short scan times, that we can really accomplish like arterial phases and really be quick and fast. So think about, this is the T1 gradient echo-based sequence, how much contrast you already have without contrast media. So I think this is really nice, thinking about when you have contrast media injected into the pages, that you will see even more on these images. Okay. One other thing, maybe while the last sequence is running, which I just want to show you one more time, in case you haven't joined our other sessions. But here, when we turn to a less S to I coverage, you see how well air touch, our coil recognition technique, does the job in knowing really where the coils are on the patient. So I don't have to like think about which coils to use. Whenever I place my field of view, the air touch knows which elements are needed in order to have a good image quality, and it really is really reactive. So I don't have to think about deactivating coil modes or making sure that that I switch coils here. The software will do that for me, and I can just relax, and I can move freely to the body, go from the head to the toe with never switching any coils, which is really, really convenient and gives you really efficiency during your daily work. And then we ended up here in the prostate with T2 image, again with and without air recon DL. So maybe I can also like make that again a little bit bigger, that we can appreciate that image a little bit more. So scan time was 2 minutes 31 seconds. Left hand side obviously with air recon DL, right hand side without air recon DL. So Pirates compatible parameters. So we had an in-plane resolution of 0.4 by 0.7, and we end up like really with these high resolution images in the prostate. And we scanned prior on him the liver. So that is really, I think, the huge advantage, that you can really move through the body and still have these small field of view scanning also possible with the airfoils.
Yeah, that's great. So we only have a few more minutes left on the call. Just wanted to open up for questions. If anybody has anything, you can feel free to ask or put in the chat, whatever your preference is.
Looks like nobody has any questions, and hopefully everybody is amazed by what we are showing here.
Hope so.
Okay.
Great. Well, guys, thanks so much for joining. This concludes our live demo sessions for this week for RSNA, but we appreciate everybody taking the time to connect with us to see our intelligently efficient solutions.
Thank you so much, and see you next year.
Thank you very much.
Bye.
Bye.